It's my pleasure to introduce a good friend, Jim Goodbar. Jim is a lifelong caver who's been involved in exploration, research, and karst management for over 60 years. He's recently retired from a 38-year career with the Bureau of Land Management as their National Senior Cave and Karst Specialist, working with cave and karst resource management both nationally and internationally. Thanks, Jim.
Well, it was really interesting hearing Andreas Fleisch's talk about the possible connections between manhole and snake trap. That was the other cave that was out in that area, which also speaks to the movement of air and a lot of the gases that can be transported through those cracks and crevices. So Kim Cunningham had done what he called the world's largest gas trace experiment. And before I get my talk started, I wanted to acknowledge Kim Cunningham for devising and conducting the experiment, and then all of the BLM, NPS, and LCP volunteers, for Hazel, of course, for getting all this going and ramrodding it through, for Harvey, Rod Horrocks, and Ellen for a lot of the information that they were helping me to amass, and of course to Andrea for some of her awesome GIS maps. To go back to get into the background a little bit more, in 1991, Yates Energy submitted their application for a permit to drill a gas well over an area called the Bowl, and that was in Dark Canyon, and it was fairly close to the Lechuguilla Cave. Because of the notoriety at that point of Lechuguilla Cave and all the work that the cavers had done, and a lot of the different kinds of publicity that Lechuguilla had, that actually triggered an environmental impact statement to be written. We tried to write an environmental assessment at first, the BLM, but it was so voluminous that and there was so much controversy about that well that they decided it was decided for us by the National Environmental Policy Act that it needed to go to an environmental impact statement. Also, John McLean was pulled in from USGS to do all of the hydrology work on that. And so there was a lot of caver involvement in that. As part of this project, the BLM also pulled together, as I think Ed LaRocque had mentioned before, a BLM cave and karst task force. And within that task force, there was a geologic subcomponent, and they worked a lot on looking at some of the geology there. It was quite an involved environmental impact statement, and it took several years to get that through. As Dale mentioned last night, there were 3 different studies that were completed as a result of that, as part of that environmental impact statement: a lineament study, a natural potential study that Art Lang came down and conducted some points on the Park Service around Carlsbad, Lechuguilla, and then several points on BLM land. And then Kim put together the Helium study. The purpose of the Helium study was to identify if there were high permeability pathways that would lead from the area around Lechuguilla Cave into the back reef of the BLM, where the potential well location was going to be. And why helium? Well, it's the smallest gas molecule. It has high transmissivity. And so we used the lineament studies and also the natural potential studies to identify where some of the recovery points for the helium might be. So after we use those, especially like the cross sections of the lineaments and all, then we identified 23 areas, 23 points where soil gas probes would be installed and monitored from the surface locations. These were basically 1 meter long probes that were driven down into the ground, And then when the samples were taken, they would take a syringe, pull the sample of gas out of it, and then inject that sample into a stainless steel cylinder. At that time, during the main during the main part of the experiment, there was a mobile lab station that Kim had set up over at the Parks motel, at the Park Motel there in Carlsbad, because some of the samples were coming from Lechuguilla Cave, and then some of them were coming from the back reef of the BLM. It would take about the same amount of time to transport those to a central point in Carlsbad where they were analyzed on the spot by Kim. So there were sampling locations. There were 9 cave locations, 2 at Carlsbad, Spider, Harvestman, and Cueva Leon, de Leon. Those were in the cavern on Park Service land, and then Mudgett's Manhole, Little Manhole, and Snake Trap, and those were on BLM. There were 4 well casings, and these were water wells that were used. One of them was an open well on Section 16 state land, and it lost circulation at about 1,000 feet and wound up just, they cased it, and but it was blowing a lot of air. So that was one of them. And then there were 6 petroleum related. Those were existing gas wells that were in that area, as well as the location for the potential Diamondback well, and also for one that was called the Sidewinder well, which was already drilled, and that was on private surface, private minerals in the bottom of Dark Canyon. And then there were 23 surface related probes related to the caves and lineaments on BLM land. So this is what the lineament study actually looked like, with the Park Service boundary being the purple line here. The little light colored area here is the Mudgett's Wilderness Study Area. And then these are a lot of the lineaments that were identified. The BLM had a Landsat imagery in the infrared and red, blue, and green spectrums run. And that's what the geologic panel used to identify a lot of the lineaments that were out there. And then using those lineaments, they identified where a lot of the probes would be set. So also where the natural potential points might be. So these are the natural potential points that Art Lang had identified, and based on some of the lineament surveys. If you look right here, that's the existing, that was the existing location of the Sidewinder well, this being the Serpentine Bends area of Dark Canyon. And then later, this is the image, this is where the Diamondback well was. Both of those wells have been plugged and abandoned since drilling. So these were the natural potential points. And so using the natural potential points and then also the lineament studies, these were the BLM surface locations that were identified. And there's some more over to the east of the map, but this is what I got on this slide here. And with Lechuguilla Cave down here. So the sampling locations and release, at noon, I mean, it was all timed and coordinated, and everybody had their watches synchronized, and it was a real big deal that August 5th, 1991, 310 cubic feet of helium gas was released there at the EY 53 survey station in Lechuguilla. There were 26 sampling stations in Lechuguilla Cave, and air samples were taken basically every 3 hours for 2 days, and then sporadically after that for the next 2.5 or so months. The actual start time of the initial sampling was kind of staggered because of the distance from EY 53, from the release location. So if you were way over in the Far East, then that would be it was like a 2-hour delay. But then the location that was really, really close to EY53, they started sampling within like 20 minutes of the release. So the last sample was taken in July of 1992, and it was about 90 days, 3 months of sampling that was going on. The gas moved at a pretty standard rate, a little bit greater than what the normal diffusion rate of helium would have been. And there was a large amount of gas that moved into the Northwest Passage. I wasn't able to find the actual data of the helium concentrations that were throughout Lechuguilla Cave, and I wasn't able to find a final report that detailed all of that. That I'm not sure if one was ever published. So if anybody out there knows of one, that would be some great information to pass along. Paul Berger seemed to have a lot better information on the length of time that it took to move to the Northwest Passage and from the release point. So Paul, you might be able to weigh in on that a little bit. The only surface location that had any elevation was one of the natural potential points, and very close to some of the limit intersections there. And it was about 9 standard deviations higher than the normal background. So that was over there. This would be the Sidewinder well. And then this would be the natural potential location that Art Lang identified. So along with that, he also identified some pretty nice galleries through his NP studies there. And those would correlate also pretty nicely with some of the galleries that he identified over at Big Manhole Cave. Since he did that one, then John McLean had come out and done some more electroresistivity over Manhole, further identified larger big galleries and open voids at Manhole. And then after that, Lewis Land came out and did another 3D electroresistivity study, and that's a published paper, so you can look that one up. But it shows some very, very, very interesting large galleries and pits, and the area is hollow over there. So nonetheless, the results then of there we go. The outcome of all of that was that it basically showed through that recovery over there by the Sidewinder well that gas could move long distances through those fractures and joints, and that the potential threat to Lechuguilla and the groundswell of support from the caving community and from the National Park and National Park Conservation Association pushed that into having Congress pass the Lechuguilla Cave Resources Protection Act. And that was one of the fastest acts that ever passed through Congress. It went through in record time. And what they did with that was it basically temporarily withdrew 6,280 acres from all federal mineral entry. And that was just north of Carlsbad Caverns. The way that the act was written, that once the Dark Canyon EIS was completed, whatever the record of decision was that was for the Dark Canyon EIS, then that decision would supersede whatever the Lechuguilla Cave Resource Protection Act had. So when the Dark Canyon EIS came out and the final was done, the record of decision was posted, it basically mirrored that 200 or 6,280 acres, it may have added a little bit more to the west towards the Forest Service boundary. But what it did then was to withdraw all minerals from any kind of entry, and that included the 1872 Mining Act as well as the Mineral Leasing Act. And so fluid minerals, gas and oil, would be leasable under the Federal Leasing Act, and so they were withdrawn. And so nobody could, additionally, nobody could go in and stake any kind of mining claims on any of the caves or mineral resources out there. So that was a real benefit. A little bit later, the report that the Geologic Committee had come up with, I felt was a little bit short. I don't think it covered nearly the amount of area that was necessary to adequately cover a lot of the potential impacts to the caverns and the cave systems in general. And so it was in 1999 that I guess that word somehow or another made it up to the Secretary's office, Secretary of the Interior, and as one of the concerns, possibly pushed more through the park, the National Parks Association, and others. Bruce Babbitt came down, the Secretary of the Interior at that time, at the end of the Clinton administration, and basically was asking information about what more could be protected. He wasn't getting a lot of answers from that and from the management. Of course, anytime big wigs like that come down, then you get this entourage of all of the state directors and district managers and all the people that want to be there. And so they didn't have the answers. And so he basically said, is there anybody that can talk to me about this? Well, little did they know that his Bruce Babbitt's background is as a geologist. And so basically they drugged me up and said, talk with this guy. And so I explained that I thought that the boundary needed to be extended westward or eastward, all the way from the Forest Service boundary over to the US Highway 62-180. And that was like a 2 or 3 mile band all across the entire top of Carlsbad Caverns National Park. And within that is a tremendous amount of the back reef, but then also a lot of the, as the reef proper, as the Capitan Reef bends, it covers a lot of that. And there's a lot of BLM caves that are over there in the reef front. Wind Cave is one of them, as well as Kaminsky's fantastic, fabulous caverns and several others that have a lot of potential to be even bigger than that. So nonetheless, once we discussed that, he basically looked over at our state director and told her to make that withdrawal happen. So in 2000, the rest of that entire area north of the caverns was completely withdrawn from all mineral entry. And so all the way from US 62-180 all westward towards to the Forest Service, all of that land has now been permanently withdrawn from all mineral entry, and basically being protected through that from any kind of oil and gas on federal lands. There are some state and private lands there that also may have some oil and gas drilling or other mining activity possible, but I can't do anything about that. So that's basically it. I know there were a lot of questions yesterday about some of the wells that were drilled up there. And so I was there when they were all drilled, and have a lot of background within that. I think the whole concept of Lechuguilla and what that has brought up in the minds of people has been just phenomenal. And then the outcome of a lot of the things that the fervor of exploration and science at Lechuguilla has brought on, one being the Dark Canyon EIS. And what that basically did, the EIS did, it formed the basis and the guidelines for pretty much most of the oil and gas drilling procedures for the future. And so a lot of the recommendations that were made during that EIS were then rolled over into resource management plans and conditions of approval and lease stipulations that are still being enforced and improved on today. And so the whole idea that the influence and impact of Lechuguilla is just within the caverns is not quite there. It's so much beyond that. It has inspired so much more resource protection in a lot of other ways that I think a lot of people may not see that or recognize it unless you're in the oil and gas industry and happen to be drilling in cave and karst areas. So I'll be done for that.
Hey, Jim, thanks. This is your co-moderator, Johanna, and we did have one question in the chat box for you so far from John Lyles. Is it possible that sample BLM number 23 in the bowl of serpentine bends could have been a burp of elevated helium from the nearby Sidewinder number 1 well?
Without looking at a lot of the data that Kim had and knowing that, it'd be hard to say. It could be. I think that if it were, then you would have seen similar things in the samples that were taken over at the Ridge Federal number 1 and the Guadalupe Federal number 1. But you didn't see it there. Or they also took samples at the Franklin Fed number 1 there in the bottom of Dark Canyon. And none of those showed any kind of elevated helium hits. And so I would think not, but one never knows.
Thanks, Jim. Next question. Can we detect gas with the air pressure waves?
I think that might be a question for someone else.
Totally fair.
Yeah, I think maybe for Andreas. But I think that I think by looking at some of the data that Andreas has about the connections between possible connections between Lechuguilla, manhole, and snake trap, that wave over time as it comes through very possibly could be detected.
Thanks, Jim. I see Andreas has popped on camera here. Andreas, do you want to speak to that question? We'll try to get you unmuted.
Okay,
there we go.
Okay. Now, so can you ask me the question again? I didn't get the beginning of it.
Sure. Can we detect gas with the air pressure waves?
So frankly, I think I don't understand the question right now. So what do you mean? Can we detect gas with it? So I think I saw another question about radon movement. So I think the air pressure waves change the airflow, and so radon moves forth and back into the cave, and so we will have some. The airflow surely will influence some gas movement inside the cave, but I don't think this is a question, right?
Was he specifically talking about the question talking about tracer gases, or what kind of gas?
Oh yeah, sure. The air pressure waves have an influence to the tracer gases. This is absolutely, we know this from other things. We used instead of helium, we used SF6, so hexafluoride, and so we know this. So, and I think if you do the helium thing again and again, you will have different results. It all depends on the airflow which is going on, and what time you bring it out. Do you have an inflow? Do you have a quick outflow again? Do you have a long inflow? So you will have various results if you do various tests.
So there's a clarification from the asker. What they're saying they mean is if they see the waves and the pressure, it means there may be gas moving, if that helps to clarify. And I see, Annika, you come on camera too, if you have something to add.
I think in order that this happens, the gas has to have quite a large proportion of the overall air. Because what we are talking about is just that we are seeing the differences from the outside due to these small tides or due to large pressure buildings. And if there are some effects inside the cave which add a large amount to the air by different gases, then it can have an effect. But I don't think that we will get into these regions by adding smaller gases like helium or things like that.
Great, thank you all for tackling that. We'll go ahead and bounce back to a question for Jim Goodbar, and then we'll start engaging in some of the other questions for you, Andreas and Annika. Thanks for being on tap for those. So Jim, there was another question in the chat box. Do these protections prevent a tourist elevator shaft in the corner of Lechuguilla that is outside the park wilderness, far west?
Wow. No, I mean, it's always possible that manhole could be the back door to Lechuguilla and the opening of a new show cave there, but I don't believe that that would be, to be serious about the question, it probably would not. But that would have to be something that would be applied for through the BLM. And I think that the BLM would probably not entertain such a proposal to dig such a shaft. That was proposed once before, actually by one of the oil companies, who said that they would gladly go up and drill a shaft into whatever part of where we thought manhole might have big caverns, big openings, big galleries, but that we decided that wasn't a good idea. So the resistivity studies that have been run and the natural potential all correlate pretty much the exact same thing, and that is within 36 feet of the ending dig point that's in manhole right now, there are large open galleries. And from the 3D seismic, or not seismic, the 3D resistivity, it's probably at the same level as the dig that we're looking at now. And there's also 30-mile-an-hour airflow that comes through the cracks that are right there. So I think the potential for opening up vast, large systems that go underneath Dark Canyon from the manhole location, and because manhole is in the crest of the anticline there, I think it would go probably fairly deep, fairly quickly. That's just my thought. But the fact that there are large anomalies that appear in the bottom of Dark Canyon, and then on the other side of Dark Canyon, on the north side at Snake Trap, and airflow studies by Andreas seem to think that they may all connect. There could be one pretty large system there. Look out, Mammoth Cave.
All right, thanks, Jim. So we're now in our open question session. So I'm going to transition to some questions that came in previously for Annika and Andreas. We will start with, it is thought that High Hopes is connected to Spider Cave. Would it be worth measuring airflow up in High Hopes, and would it tell you anything new?
I'm very sorry. frankly, I don't know where this location is.
High Hopes is up in where you had that blue patch to the west showing the barometric flow is at the very top end of that. So it's about, I'm not quite sure, what might be 150 meters above the level of the main room. And it's the bit that's pointing out towards Spider.
So is it the New Mexico room area?
Is that the name of that room? I think so. Somebody's probably gonna ping
So I
in
know.
the thing.
So if it's this area, so we tried to figure out what's going on there. We couldn't detect anything with the temperature measurement, so we would have to put a sonic anemometer in to really find some information about it. We never did this. It was in the schedule, but we never did it. So the temperature was has no variation. So we couldn't find any signal till now. So you really have to do good airflow measurements with the sonic. So yeah, we didn't do it yet.
Okay.
I just got pinged. It's the it's above the New Mexico room.
Yeah.
And the passages get pretty small and narrow there, so it might be possible to measure something there that you wouldn't get in the big passages.
Yeah, so what I said, with the sonic we can do it, but not with the temperature method. So, and this is more work, and we need electricity and all this stuff. So using a sonic is always more difficult because of the power consumption. If we one day have really nice batteries lasting longer, having more power, then it would be much easier to do this. But right now we have to carry a lot of batteries, or we need to have constant power.
Okay, so next question. There was some appreciation in the chat box for the time and temperature resolution of the data from left-hand tunnel to Andreas and Annika, and a question related to that. What is the resolution of those data, and what kind of resolution do you need for an analysis?
So we usually use 5 minutes. If we can't go to the cave, we take more 10 minutes because we never took into account to have a COVID problem. But I always thought, oh, I might not have money to come back, or there might be other problems with the health or whatever can happen. So 10 minutes gives us a long enough period, but the resolution is really on the edge with 10 minutes. 5 minutes is much better. And then we have data for a long time, and we have a good enough resolution to see the effect of barometric caves. Because you have to take into account, Lechuguilla is great. Lechuguilla has like Jewel Cave in South Dakota. It has really long periods. But for instance, Wind Cave has much shorter periods, and the smaller the cave gets, the shorter is the effect of a barometric airflow. And so 5 minutes, it's really good. You have enough battery, you have enough space on the data logger, and a good resolution. 1 minute we would have the problem with the space on the data logger and the power consumption. So usually it's 5 minutes, and that's what we have in the left-hand panel as well. It's 5 minutes, and
yeah. For pressure, it's very different.
Yeah, that's
because
right.
For pressure, we did 10 seconds in the left-hand tunnel, and that wasn't good enough. So we have to do it again, because the problem is that before you do your measurements, then you don't know how long this time shift can be between the outside and your measuring point inside the cave. And when the shift is as long as it is in Lechuguilla, which is more than 1 day, as you've seen, then maybe even 5 minutes for the pressure would be okay as well. But then when we look into left-hand tunnel, we cannot see anything if we use 10 seconds. So now we will do the experiment again, do it with 1 second, and then see whether the shift is just shorter than these 10 seconds or whether there is no shift. So it really always depends on the differences between the inside and the outside. And the larger they are, the smaller the temporal resolution can be.
Okay, thanks. All right. Next question. Do you think that the large number of human entries in Carlsbad Caverns can significantly enhance the airflow by causing turbulence and mixing, or do you think it is insignificant compared to the external atmospheric drivers?
Yeah, I think this question is from Penny, and I can say something about it. So what we have figured out, so we did measurement in the big room in Karlsbad, and we were really lucky to have measurements during the shutdown periods in the US. So we haven't had any tourists for a while into the cave. So interestingly, in the big room, just below the ceiling, where I really expected some influence, I couldn't see anything. So, but the data measured close to the floor showed us a daily variation of temperature caused by the tourists and caused by the lights in the big room switching on. But during in the period without any tourists during the shutdowns, we couldn't see the signals. So everything was cooling down really slowly. And as soon as the tourists came back and the lights were on, we saw the influence. So the tourists and the lights definitely have an influence. They cause turbulence, and they might change even the airflow. But we never have measurements about the effects of the airflow. But I think in general, the airflow is on a bigger scale, and the tourists might not stop the airflow or whatever, but they influence the airflow, and they definitely influence the temperature regime in the cave. But more or less in the rooms where we have really slow airflow, like the big room. I don't think there's any big influence in the passages which are narrow and you really can feel the airflow. It goes around the people. But okay, they bring humidity in, they bring CO2 in, all this stuff. So that definitely there is an effect. And I would like to answer another question, which is close to this about the influence of the elevators. This is a thing I know from Wind Cave. We have an influence of the elevators. And it's the moving, so the piston effect of the moving up and down, and we have an influence to the airflow, we have an influence to the temperature around the elevator shaft. But in Karlsbad, we're going to start this experiment in a week or two. This is on the list, and we are doing a special experiment with the pressure loggers, what Annika said, with a resolution of 1 second, that we can find out every influence by the elevator.
Thanks, Andreas, and thanks for catching that question in the chat box. I saw it and thought also that it was related, so I was going to go there next. So thanks for capturing that. I do have another question in the chat box for you, Jim, from Larry Spangler. Can you give more details as to how the helium was transported into the cave and released?
Yes, there were. It was pretty interesting. I had an opportunity to talk with Kim quite a lot on that. And what they did was they took 3 cylinders of helium gas in, and when they released it, there was some concern that the helium would crowd out a lot of the oxygen. So he also took in an SCBA with face mask and an air breathing tank. And so when he released all the helium, he was fully dressed in his SCBA with visor and hood. So that was all. It's kind of like a diving expedition where you're transporting all these tanks in there. But that was basically how it was done in 3 helium cylinders and 1 SCBA.
Great, thanks, Jim. Okay, back to Andreas and Annika. Why do you hypothesize that Lechuguilla, manhole, and the blowholes to be connected in one large system as opposed to separate barometrically controlled systems?
Yeah, I saw this this question before, and this is a question I was asked in the Black Hills many times. So with the experience in the Black Hills, we know each barometric cave has its own fingerprint. So what we look for is we are looking for the patterns. So how good do the patterns match? And, you know, I was short in time, and I have slides about this, how we can prove this is one system, this is our two systems. And so the fingerprint between big manhole and the blowholes and Lechuguilla are so well, they are matching so good, it must be one system. And I could show you a comparison between Wind Cave and Jewel Cave, which we know these are two big systems in the Black Hills, and they are very different. And then we have these little caves like North Cave and Jasper Cave and S&G Cave, and they match very good to Jewel or to Wind Cave. And so with this experience, we know each big system has a fingerprint. And this is why I hypothesize that we have one huge system around Lechuguilla.
Thanks, Andreas. Okay, question in the chat box. Years ago, we were told that barometric studies in Lechuguilla made an estimate of 1,600 miles of cave. Do any of these recent studies change this estimate in any meaningful way?
Frankly, unfortunately, I can't say anything about it. For this, we really need longer measurements. We did in 2010 a study. We put a sonic in the opening of the airlock, and we opened it for a few days, and we got wonderful data. And I remember Paul Berger carried so many batteries over that we could do this study, and helped me a lot. And I really would love to do this study again, but the season was not a good season. We did it in the summer. I would really like to do it in the late winter or in the winter, because we have much better variation, and we need a longer period. Then we could maybe make another estimate with better data. We did the same for Wind Cave and Jewel Cave, and we told them already 15 years ago. So Jewel Cave is 10 times bigger, and they are finding more and more and more and more. So it's going on. So we could do this study, but this takes a lot of measurements, and we really have to open the cave and have good airflow data. So we need the volume going in and out, and for a longer observation. But I think we will never do this, because we can't have the cave open that long.
Okay, great. One more question. We have 2 minutes remaining, and then we need to go over to the next talk. So one last question. I know there's been lots of great questions in the chat box. We won't get to them all. So Jim, Andreas, and Annika, you can hop over there when we're done with this. And if there's any way you can answer some questions for folks, that would be great. But the last question, there's actually two that are related to the Lechuguilla entrance and airflow at Big Manhole. If a check valve was placed at the Lech entrance, would the airflow at Big Manhole change? And then there's also a question about attaching some kind of valve to Lech's gate to introduce a barometric signal at low frequency to be observed elsewhere. So I don't know, with only a minute or so remaining, if you can speak to that, but I'll give you some space here, and thanks.
Wait, I have to look to this question. So observe good electric. I think I don't get this question in the right way. So I think I have a misunderstanding. I don't get it.
Okay, that's all right. What I would suggest is, Gary, if you could add some clarification to your question in the chat box, and then Andreas, Annika, maybe if you can chat with him there to help.
Yes, we can do this. Yes.
Great. Awesome. Thank you so much. Well, thank you, Jim and Andreas and
Thank
Annika,
you.
for your presentations and for your time in answering questions. And we're going to go ahead and transition over to Jake.